Hello students, welcome to Deksha Karnataka YouTube channel. Today I am going to discuss top 30 questions in ray optics and optical instruments. Okay, so every year in KCET they ask minimum 3 to 4 questions from this chapter. Okay, so if you are able to solve these questions, that is these 30 questions, so it will be assured that you can easily counter these kind of questions in the exam. Okay, so in the exam they will ask these kind of questions only. Okay, yeah, let us start. Question number 1. For a given pair of transparent media, the critical angle for which color is maximum. Okay, we know that sin c, that is c is critical angle, which is equal to 1 divided by mu, right, which is equal to 1 by mu. So this is the denser medium. Okay, denser medium, and this is rarer medium. Okay, the light ray here, the light ray moves from denser medium to rarer medium. So this is the interface, right, second medium and that is denser medium and rarer medium interface, right. So here light ray moves along the surface of this interface. Okay, here the angle of refraction is 90 degree, right, angle of refraction is 90 degree. So now apply Snell's law. Okay, so this angle is critical angle. Okay, if the angle is increased, that is if the incident angle is greater than c, then the refracted ray, so there will be a total internal reflection. Okay, there will be a total internal reflection. Now here if you apply Snell's law here, so you will get sin c equal to 1 by mu. Okay, sin c equal to 1 by mu. We know that the refractive index mu equal to a plus b by lambda square plus c by lambda to the power 4 and so on, right, isn't it? So what is this? This is Cauchy's formula, right, isn't it? Cauchy's formula. So refractive index is equal to a plus b by lambda square plus c by lambda to the power 4 and so on, right. So as the value of lambda increases, mu value decreases, right, vice versa, as the value of lambda decreases, mu value increases, right. So violet has the lowest wavelength, right, red has the highest wavelength, isn't it? So they are asking given pair of transparent media, the critical angle for which color is maximum, right. So for violet color here, the critical angle is maximum, right. Why? Because lambda is the lowest for violet, right. So option C is the correct answer. Okay, yeah. Next question, question number 2. An equiconvex lens made of glass of refractive index 3 by 2 has focal length f in air. It is completely immersed in water of refractive index 4 by 3. The percentage change in the focal length is. Okay, so the percentage change in focal length is final focal length, that is the focal length of the equiconvex lens when it is immersed in water, right? Yeah, when it is immersed in water, minus focal length of the equiconvex lens when it is in air divided by f into 100%. Okay, so this is the percentage change in focal length. Let us find f dash. Okay, f dash, right. Here we need to use lens maker's formula, right. We know that lens maker's formula 1 divided by f equal to relative refractive index mu minus 1 into 1 by r1 minus 1 by r2, right. So it's a equiconvex lens, right. So r1 equal to r, r2 equal to minus r, right, r2 equal to minus r, isn't it? And then mu is 3 by 2 when it is in air, right. Now 1 divided by f equal to 3 by 2 minus 1, right. So 3 by 2 minus 1 is 1 by 2. So 1 by 2 into 1 by r1 minus 1 by r2, that is 2 by r, right. 1 by r minus of minus 1 by r, that is 2 by r. This is the focal length of the equiconvex lens when it is in air, right. F is focal length of the equiconvex lens when it is in air. Now it is immersed in water. right? Now 1 by f dash is the focal length of the equiconvex lens when it is in water, which is equal to relative refractive index. Here relative refractive index, mu relative, is equal to refractive index of the glass with respect to the refractive index of the water. Okay, so what is the refractive index of the glass? That is 3 by 2. Refractive index of the water is 4 by 3. So 3 by 2 by 4 by 3 is 9 by 8, right? So 3 by 2 by 4 by 3 is 9 by 8. 9 by 8 minus 1 into 2 by r. So what is 9 by 8 minus 1? So it's 1 by 8, right? So 1 divided by f dash is equal to 1 divided by 8 into 2 by r. Okay, so this is the second equation, and here this is first equation. Now divide first equation by second equation. Okay, divide first equation by second equation. So this will be 1 by f dash, that is equal to f dash divided by f, right, which is equal to 1 by 2 by 1 by 8, right? 2 by r will get cancelled, isn't it? 1 by 2 by 1 by 8 will be 1 by 1 by 4, right? So f dash is equal to 4f, right? F dash is equal to 4f. So we got the value of f dash, right, in terms of f, right? So now use this formula, percentage change in focal length. F dash is 4f, 4f minus f, 3f, right? 3f divided by f into 100%. So which is equal to 300%. Now focal length increased or decreased? Here the focal length is increased, right? Why? Because it's positive 300%, right? So option C is the correct answer. Okay. Yeah, next question. Question number 3. A point object is moving at a constant speed of 1 meter per second along the principal axis of convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second when the object is at dash centimeter from the optic center. Okay. Here we have convex lens, right? Convex lens. Object is moving at a constant speed 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. So the velocity of the point object is 1 meter per second. Velocity of the point object is 1 meter per second. Okay. Focal length of this convex lens is 10 centimeter. Okay. So we the speed of the image is also 1 meter per second, right? Speed of the image is also 1 meter per second. Okay. Here speed of the image, right, Vi is equal to 1 meter per second. This is Vu. Okay, or VO. Okay, VO is 1 meter per second. When the object is at, okay, so here we know that the lens formula 1 divided by V minus 1 divided by U equal to 1 by F, right? Now differentiate both sides with respect to T. Okay, I am deriving this. Okay, you should remember the last result. Okay, so I am deriving this one, that is the relationship between velocity of the object and velocity of the image. Okay, so now differentiate both sides with respect to T. If you differentiate both sides with respect to T, you will get minus 1 divided by V square. Okay, minus 1 by V square into dV by dt, minus into minus plus, right, plus 1 divided by U square into du by dt, which is equal to 0. Focal length of the lens is always constant, right? So now what is dV by dt? dV by dt is velocity of the image with respect to the mirror. Okay, du by dt is velocity of the object with respect to the mirror. Okay, so now take 1 by u square du by dt to the other side. We will get v square, here dv by dt, velocity of the image with respect to the mirror, is equal to here v square by u square. V by u is magnification of the lens, right? So that will be square of the magnification of the lens into velocity of the object with respect to the mirror, right? So you should remember this formula, okay? So this is the end result of this one. Now velocity of the image with respect to the mirror. What is the velocity of the mirror? It's 0, right? So velocity of the image with respect to the mirror is 1 meter per second, right? Which is equal to m square. M square is v square divided by u square into what is the velocity of the object with respect to the mirror? It's 1, right? 1 meter per second square, right? So we need to find the value of u, right? Okay, so we don't know the value of v, right? So but we can write v in terms of focal length and u, isn't it? So from the lens maker's formula, here I can write this equation as, anyway u equal to minus, right? U is negative, so 1 by v is equal to 1 by f, right? U is negative anyway, so this will be positive, so 1 by f minus 1 by u only, right? So v equal to f into u divided by u minus f, right? V equal to f into u by u minus f. Now substitute the expression of v to this equation. Now v square is equal to u square, right? V equal to f into, okay, take square root on both sides, it will be v equal to u only, right? So f into u divided by u minus f equal to u square, right? U squared, isn't it? So now f is given, right? So we need to find the value of u. So anyway u will get cancelled, right? U and u will get cancelled, isn't it? It is not u squared, it's u only, okay? It is u only. So u will get cancelled, f equal to u minus f, so u equal to 2f, right? U equal to 2 times f, that is 2 into 10 centimeter, that is 20 centimeter, right? 20 centimeter. Here this is f, right? U equal to 20 centimeter. So option B is the correct answer. Question number 4. For a point object, which of the following always produces virtual image in air? Okay, so virtual image in air. So concave mirror and convex lens. Here image produced by concave mirror and convex lens is always real, right? Isn't it? Most of the times it's real, right? It's real. So option A is wrong. Option B, convex mirror and concave lens, correct, right? Image produced by convex mirror and concave lens is always virtual, okay? So option B is the correct answer, okay? Option C, concave mirror and convex lens, concave lens. So this one is correct, this one is wrong. So option C is wrong. Option D is also wrong anyway, convex mirror and convex lens, okay? Yeah. Next question. Sorry, here convex lens is correct, convex mirror is correct, okay? Convex lens is wrong. Yeah. Next question, question number 5. Consider a glass slab which is silvered at one side and the other side is transparent. Okay, so this is the glass slab, okay? One side is silvered, the other side is transparent. Given the refractive index of the glass slab to be 1.5, here refractive index of the glass slab mu equal to 1.5, okay? If a ray of light is incident at an angle of 45 degree, here this is the ray of light, okay? Angle of incidence is 45 degree. On the transparent side, the deviation of the ray of light from its initial path when it comes out of the slab, okay? So here there will be a refraction, right? Isn't it? Right? So at this point there will be a reflection, right? And then refraction, isn't it? So here the angle of refraction is 45 degree, right? Angle of refraction is 45 degree. Apply Snell's law at this point, then here you will get the value of here r, right? The value of r is same as here r, right? Then angle of incidence is equal to angle of refraction, right? Reflection, okay? This will also be r. then this will also be r. Here you will get 45 degree only, the same value, 45 degree. Okay. Okay. Now I can redraw this diagram as like this, right? 45 degree and 45 degree. So I need to find the deviation, right? So extend this line, isn't it? So if it is 45, then this will also be 45. If this angle is 45, then this angle will also be 45. This angle is 45, 45. So opposite angles, 45 degrees. So 45 plus 45, 90, right? Angle of deviation delta is equal to 90 degree. So the correct option is B. Okay. Yeah. Next question. Question number 6. Focal length of the convex lens will be maximum for. Okay. So lens maker's formula, according to lens maker's formula, 1 divided by f equal to mu minus 1 into 1 divided by r1 minus 1 divided by r2, right? So from this I can conclude that focal length is inversely proportional to mu minus 1, right? And we know that the Cauchy's formula, refractive index mu equal to a plus b divided by lambda square plus c by lambda to the power 4 and so on, right? Isn't it? So as the value of wavelength increases, mu value decreases. As the value of wavelength decreases, mu value increases. What they are asking? They are asking focal length of the convex lens will be maximum for, right? So here, to be focal length to be maximum, then mu value has to be minimum, right? So which color has the lowest refractive index value? So the color has the maximum wavelength, right? The red color has the maximum wavelength, right? Red color has the maximum wavelength. So refractive index of the red color is lesser compared to the refractive index of the green, blue, yellow lights, isn't it? Refractive index of the green, blue, yellow, right? Refractive index of the red is lesser than refractive index of the green, blue, yellow, isn't it? So therefore the focal length of the convex lens is maximum for red color, right? Focal length of the convex lens is maximum for red color compared to green, blue and yellow. So the correct option is C. Next question, question number 7. A ray of light passes through an equilateral glass prism in such manner that the angle of incidence is equal to angle of emergence and each of the angles is equal to 4/3 of the angles of the prism. The angle of deviation is, okay, here angle of incidence is equal to angle of emergence, right, according to the question. And then here angle of incidence and angle of emergence is equal to 3/4 of the angle of the prism. A is the angle of the prism, right, isn't it? Right, angle of the prism. So I equal to E equal to 3/4 times angle of prism, right? We need to find angle of deviation. We know the relationship between angle of deviation, angle of incidence, angle of emergence and angle of prism, right? So angle of deviation delta is equal to I plus E minus A, right? Delta is equal to, here I equal to E, right? So I can write 2 times I minus A, right? I is 3/4 times A. So delta equal to 3/4 into 2A minus A. So this will be 2, right? So delta is equal to 3A/2 minus A. So 3A/2 minus A is 1/2A, right? Delta equal to 1 divided by 2 into A, right? A is angle of prism, right? So what is the angle of prism? So here they have given equilateral glass prism, right? So it's a equilateral glass prism, right? That is angle is 60 degree, right? So A is equal to 60 degree. So 60 degree by 2, which is equal to 30 degree. So the correct option is C. Okay. Question number 8. A convex lens of focal length L is placed somewhere in between an object and a screen. Okay, so let's draw the diagram. So convex lens, okay, focal length of the convex lens is L, okay, placed somewhere in between an object and the screen. So this is the object and this is the screen. The distance between the object and the screen is x. Okay, so the distance between object and the screen is x. If the numerical value of the magnification produced by the lens is m, then the focal length of the lens is, okay, we need to find the expression of focal length in terms of m and x, right? Okay, let's find v, that is image distance, and let's find u, object distance. We can easily find focal length. Okay, u and v in terms of m and x. Okay, yeah. So what is the object distance here? The object distance will be v minus x, right? V minus x, v minus x. Image distance is here u minus x, right? U minus x. So this is minus of v minus x. Okay, minus of v minus x. Okay, so here magnification of the lens, convex lens, m equal to v divided by u, right? M equal to v by u. So v equal to m into u, right? V equal to m into u. U is minus of v minus x, right? Okay, so now here 1 divided by f, okay, we can find v, right? V in terms of, let's write v in terms of x. Okay, here v equal to m into u, right? So v equal to m into u is minus of v minus x, right? So v equal to here m into minus m into v, right? Minus m into v, then plus m into x, right? So m into v, sorry, here v into m plus 1, right? Now solve this. Here v into m plus 1 is equal to m into x, right? V equal to m into x divided by m plus 1, right? Now we got the expression of v, right? So now v equal to minus of v minus x, right? Isn't it? Sorry, v equal to mx by m plus 1, right? U equal to minus of v minus x, right? So u is equal to v minus x, right? Isn't it? Let's find u. Okay, then while applying lens formula, then we can take the negative sign. Okay, so u equal to v minus x, right? So v is mx divided by m plus 1, m into x divided by m plus 1, here minus x, right? So solve this. Okay, solve this. Here u equal to mx minus x divided by here this will be m plus 1, right? So the value of u is equal to minus x divided by m plus 1, right? So we have the expression of u and v in terms of x. Now we can easily find the focal length. Apply lens formula, 1 divided by f equal to 1 by v minus 1 by u. Okay, so u is negative, so negative into negative, positive. Okay, now here 1 divided by f is equal to okay, so here it is negative only. Okay, negative only. I will tell why. Negative only. Okay, yeah. Now 1 by f is equal to 1 by v. V is mx by m plus 1. 1 by v is m plus 1 divided by mx. Now negative of negative, right? So this will be positive, right? Isn't it? So negative of negative, this one, right? So this will be positive. So plus m plus 1 divided by x, right? M plus 1 by x, isn't it? So now 1 divided by f is equal to, here x, take m plus 1 as common, okay, x plus mx divided by m into x square into m plus 1. Okay, so now solve this, you will get the focal length f is equal to m into x divided by m plus 1. Okay, so the correct option is here B. Okay, m into x divided by m plus 1 whole square. Okay, m plus 1 whole square, m plus 1 whole square, not m plus 1, m plus 1 whole square, mx divided by m plus 1 whole square. Yeah. Next question, question number 9. The power of an equiconcave lens is minus 4.5 diopter and is made of a material of refractive index 1.6. The radii of curvature of the lens is. Okay, so here we have to use lens maker's formula, right? So 1 by f is equal to relative refractive index mu minus 1 into 1 divided by r1 minus 1 divided by r2. Okay, 1 divided by r1 minus 1 divided by r2. Okay, so here r1 equal to r, r2 equal to minus r, right? So 1 divided by f is equal to mu minus 1 into 2 by r, right? So it's a equiconcave lens, right? So it will be 2 by r. So mu is 1.6, right? So 1 divided by f, f is focal length, right? 1 by f is power of the lens, right? Power of the lens, isn't it? Power of the lens, power is equal to 1 divided by f, right? Now the focal length is equal to 1 divided by p, that is minus 4.5 diopter. Okay, so what is diopter? Diopter is per meter, right? 1 meter is 100 centimeter. So f equal to minus 100 divided by 4.5, right? So 4.5 is 9 by 2, right? So 1 by 9 by 2 is 2 by 9. So 2 into 100 is 200. So f equal to minus 200 divided by 9, right? So now substitute the value of f. So minus 9 divided by 200 equal to mu. Mu is refractive index of the equiconcave lens. So that is 1.6, right? So 1.6 minus 1 into 2 divided by r, right? 1.6 minus 1 is 0.6. So minus 9 divided by 200 equal to, here 0.6 into 2 is 1.2. So 1.2 divided by r. So now solve this, okay? You will get r equal to that is radius of curvature or radii of curvature, r equal to here minus 26.6 centimeter. So the correct option is B. Okay. Yeah. Question number 10. If the refractive index from air to glass is 3 by 2 and that from air to water is 4 by 3, then the ratio of focal length of the glass lens in water and in air. Okay. Again, here we have to use lens maker's formula, right? The lens maker's formula is 1 divided by f equal to relative refractive index minus 1 into 1 divided by r1 minus 1 divided by r2. Okay. So here r1 equal to r, right? Okay, anyway 1 by r1 minus 1 by r2, right? Okay, let's keep in that way only. Yeah. Now here for in air, the glass has refractive index 3 by 2. The relative refractive index is 3 by 2. 3 by 2 by 1 is 3 by 2 only, right? So 1 divided by Fa. Fa is refractive index of the glass when it is in air. So 1 by Fa is equal to here 3 by 2 by 1, that is 3 by 2. 3 by 2 minus 1 into 1 by r1 minus 1 divided by r2. Okay. So 1 divided by Fa is equal to 1 divided by 2 into 1 by r1 minus 1 divided by r2. Okay. Similarly, here 1 divided by L, okay, FL, that is L is liquid, okay, which is equal to relative refractive index, that is refractive index of the glass with respect to the water. Okay, let's write FW. FW. Okay, so mu relative is refractive index of the glass with respect to water. So refractive index of glass with respect to water is 3 by 2 by 4 by 3. That is 9 divided by 8. 9 by 8 minus 1 into 1 by R1 minus 1 by R2. Right? So 1 divided by FW is equal to 1 divided by 8 into 1 by R1 minus 1 by R2. Okay. So now I need to find focal length of the glass when ratio of the focal length of the glass lens in water and in air, right? Now divide the equation 2 by equation 1. Okay, sorry, divide equation 1 by equation 2. Divide equation 1 by equation 2. Okay, divide equation 1 by equation 2. Okay, so now this will be FW divided by FA is equal to here 1 by 2 by 1 by 8. 1 by R1 minus 1 by R2 will get cancelled. Okay, 1 by R1 minus 1 by R2 and 1 by R1 minus 1 by R2, these two will get cancelled. So this will be 1 by 4. 1 by 1 by 4 is 4. So FW is to FA is equal to 4 is to 1. So the correct option is D. Okay. Yeah. Next question. Question number 10. Question number 11. Okay. Two thin biconvex lenses have focal lengths f1 and f2. See, biconvex lenses, that is radii are equal. Okay, both sides have equal radii, f1 and f2. A third thin biconcave lens has focal length f3. So biconcave lens, right? So focal length will be negative. Right here the focal lengths are positive. If the two biconvex lenses are in contact, the total power of the lens is P1, right? So total power of the lens is P1 here. Okay, power is reciprocal of focal length. Remember, if the first convex lens is in contact with the third lens, the total power is P2. If the second lens is in contact with the third lens, the total power is P3. Second lens is in contact with third lens, the total power is P3. Then, okay, we need to find powers in front in terms of focal length, right? Okay, so first two lenses, right? The first two lenses, that is convex lenses, are in contact, right? The total power is P1, right? So equivalent power, sorry, before that, let's find equivalent focal length. So equivalent focal length when two lenses are in contact, 1 divided by F equivalent is equal to 1 by F1 plus 1 by F2, right? So 1 divided by F equivalent is power of the combination, right? Combination of lens. P1 is equal to F2 plus F1 divided by F1 into F2, right? So option A, B, C all are eliminated, right? Okay, let's check. Let's solve the other two also. Okay, anyway option D is correct. Let's solve the other two also. Now P2 is equal to same, apply the same formula. Okay, so here P2 is the power of the first lens and the third lens. The focal length of the third lens is negative, right? So this will be 1 by F1 minus 1 by F3, right? So the power of the second combination, that is P2, is equal to F3 minus F1 by F1 into F3. Okay, correct? Yeah, correct, right? Let's find P3 also, right? P3 is equal to 1 by F2 minus 1 by F3, right? The combination of second lens and third lens. So P3 is equal to F3 minus F2 by F3 into F2, right? Again, the third one is also correct. So the correct option is D, right? Yeah. Next question, question number 12. The size of the image of an object which is at infinity as formed by convex lens of focal length 30 centimeter is 2 centimeter. Okay, so here the object is at infinity. Okay, object is at infinity. Here we are using which lens? Convex lens, right? And image is formed, right? Height of the image or the size of the image is 2 centimeter. If a concave lens of focal length 20 centimeter is placed between the convex lens and the image at a distance 26 centimeter from the lens. Okay, let's draw the diagram. Here this is convex lens, right? Isn't it? So object is at infinity, right? So the rays are coming from the infinity, isn't it? So if rays are coming from the infinity, it converges at the focus, right? Yeah. So what is the focal length? Focal length is 30 centimeter, right? If a concave lens of focal length 20 centimeter is placed between the convex lens and the image, right? So here they have placed the concave lens between convex lens and image, right? At a distance 26 centimeter from the lens. Okay. Somewhere here image will form, right? So here they have placed the concave lens, right? 26 centimeter. So the remaining will be 4 centimeter. Okay, let's see. Okay, yeah, 26 centimeter from the lens. The new size of the image is, okay, so here the size of the image is 2 centimeter, right? And image forms at the focal length of the concave lens, right? The focal length of the concave lens, right? The focal length of the concave lens, right? Isn't it? And here focal length of the concave lens, isn't it? So this image acts like an object for this concave lens, right? This image acts like an object for concave lens, isn't it? So what is the distance between concave lens and the image, the first image I1? So this is 4 centimeter, right? What is the focal length of the convex lens? It's 30 centimeter. So 30 minus 26 is 4 centimeter. So now this image acts like an object for concave lens, right? Concave lens. So here the object distance U2 is equal to 4 centimeter, right? Positive 4 centimeter. Why? Because the measurement of object distance is same. Here the measurement of the object distance is same as the measurement of the, the direction of the measurement of the object distance is same as the direction of the incident ray, right? So U2 equal to 4 centimeter, right? Isn't it? So we need to find the height of the new size of the image, right? Okay. So now U2 we got, right? U1. Here we need to find V, right? So let us find V using lens formula. So 1 divided by F is equal to 1 by V minus 1 by U. U is positive only, right? So 1 divided by F minus 1 divided by U equal to 1 by V. So what is the value of F? Here the value of F is minus 20 centimeter because it's a concave lens, right? So minus 1 by 20 minus 1 divided by U. U is here 4 centimeter, right? Isn't it? So minus 1 by 4, this is plus 1 by 4. Okay, plus 1 by 4 is equal to 1 by V. Okay, now take 1 by 4 as common. So this will be 1 minus 1 divided by 5. So 1 by 4 into 4 by 5 equal to V. So 4 will get cancelled. V equal to 5 centimeter. Okay, so now the image will form at 5 centimeter, right? I2. V equal to 5 centimeter. Then here let us find the new size of the image, right? So what is the object distance? 4 centimeter, right? Here what is the size of the object? Here 2 centimeter, right? This image acts like a object for concave lens, right? So 2 centimeter. So height of the image divided by height of the object is equal to V divided by U for lens. Height of the image by height of the object is magnification. Magnification of the lens is equal to V by U, right? So height of the image we need to find, which is equal to height of the object into V divided by U, right? So now substitute the values, that's it. So HI is equal to V. What is the value of V? Here V is 5 centimeter, right? 5 divided by U. U is here 4 centimeter into 2, right? So this will be 2. 2 by 4 is 1 by 2. So 5 by 2 is 2.5. So height of the new image is equal to 2.5 centimeter. So it's a positive, right? That is erected. So the correct option is B, right? Yeah, next question. Question number 13. The refracting angle of prism is A, that is angle of prism, okay? Angle of prism. Angle of prism is A, and refractive index of the material of prism is cot A by 2. So mu equal to cot A by 2. The angle of minimum deviation is the direct question, right? So here we know that refractive index of the prism formula, right? So refractive index of the prism mu equal to sine of A plus delta m divided by 2. Delta m is angle of minimum deviation, whole divided by sine of A by 2, right? Mu equal to cot A by 2. Cot A by 2 is equal to sine of A plus delta m by 2 whole divided by sine of A by 2. Cot A by 2 is cos A by 2 divided by sine A by 2, right? So now sine A by 2, sine A by 2 will get cancelled. So cos A by 2 is equal to sine of A plus delta m by 2. A plus delta m divided by 2. Okay, so now I can write cos in terms of sine, right? So cos 90 minus theta, right? Cos 90 minus theta is sine theta, right? So cos 90 minus theta is sine theta, isn't it? Sorry, here sine 90 minus theta is cos theta, okay? Sine 90 minus theta is cos theta, right? I can write cos A by 2 as sine pi by 2 minus A by 2, right? Sine pi by 2 minus A by 2. Sine 90 minus theta is cos theta, equal to sine of A plus delta m divided by 2, right? So now solve this, okay? Then you will get angle of minimum deviation is equal to here pi minus A, right? Sorry, here this will be pi minus 2A, not A, okay? Pi minus 2A. So this is the correct answer. Pi is 180 degree, right? So 180 degree minus 2A. So option B is the correct answer, okay? Yeah. Next question, question number 14. An object approaches convergent lens, that is convex lens, okay? Convex lens. So this is how I represent convex lens, okay? From the left of the lens with the uniform speed 5 meter per second and stops at the focus, the image, okay? So this is the convergent lens, okay? Object is coming from infinity with the velocity v equal to 5 meter per second. Velocity v equal to 5 meter per second, and it stops at the focus, right? It stops at the focus f1, f2. f1 equal to f2, okay? Stops at the focus, the image, okay? So here image moves with a non-uniform acceleration, right? Isn't it? Image moves with non-uniform acceleration and it moves away from the lens, right? Okay, let's see how. So here, when object is at infinity, what is the position of the image? The position of the image is at focus, right? Isn't it? So as you move towards the lens, okay, as you move towards the lens, image will start to move away from the lens, right? Isn't it? So when the object is at 2f1, okay, 2f, the image will also be at 2f, right? So that is, it is moving away from the lens, right? So moving away from the lens, see here it's 5 meter per second, right? So here the image has to move from f2 to f2, right? Object is coming from infinity, right? Infinity to 2f. Here image is moving from f2 to 2f2. So the here the velocity of the this image, velocity of the image is lesser than velocity of the object, right? So it's a non-uniform acceleration, right? Okay, it moves with some acceleration a. Okay, now object moves from 2f to f1, right? When object moves from 2f to f1, object moves from image moves from 2f to infinity, right? When object moves from 2f to f, image moves from 2f to infinity, isn't it? Right? Image moves from 2f to infinity. So in this case, velocity of the image is greater than velocity of the object, right? Velocity of the image is greater than velocity of the object, right? So look here, the acceleration is not uniform, right? Isn't it? Acceleration is non-uniform, isn't it? And it is moving away from the lens. So the first option moves away from the lens, correct, with non-uniform acceleration, correct. So option A is the correct answer. Okay. Yeah. Next question, question number 15. The following figure shows a beam of light converging at point P when the concave lens of focal length 16 cm is introduced in the path of the beam at a place shown by dotted line, such that OP becomes the axis of the lens. OP becomes the axis of the lens. The beam converges at a distance x from the lens. The value of x will be, okay, so here we have placed concave lens. This is how I represent concave lens, okay. So these are the converging rays, right? These are the converging rays, isn't it? So here the beam converges at a distance x from the lens, right? Distance x from the lens. So this is the point P, right? Here this is the light rays converging at point P before we are keeping the lens, the concave lens, right? So we need to find the value of x, right? So here it's 12 centimeter, right? 12 centimeter. So this point P here, the image, the point P acts like an object for this concave lens, right? So it's a virtual object, right? So this virtual object here, this image acts like an object for concave lens, that is virtual object. So apply lens formula. So 1 divided by f equal to 1 by v minus 1 by u. Okay, f is given, v is, u is given, we need to find. F is minus 16 centimeter, right? Why it is minus 16? Because it's a concave lens. Concave lens is diverging lens, right? So 1 divided by minus 16 is equal to 1 by v minus 1 divided by 12 centimeter only, right? U equal to positive because the direction of the measurement of u is opposite to the is same in the direction of the incident ray, okay? The direction of the measurement of u is in the same direction of the incident ray. Now 1 divided by v is equal to 1 divided by 12 minus 1 divided by 16, okay? 1 by 12 minus 1 by 16. Now 1 divided by v is equal to take 1 by 4 as common, right? So 1 divided by 4, now 1 by 3 minus 1 divided by 4. So 4 minus 3, 1, right? 4 3s are 12. So V equal to 48 centimeter. So the correct option is B. Okay. Yeah. Next question. Question number 16. A certain prism is found to produce a minimum deviation of 38 degree. Okay. Delta M equal to 38 degree. It produces a deviation of 44 degree when the angle of incidence is either 42 degree or 62 degree. Remember, you remember this graph, angle of deviation versus angle of incidence, this graph, right? So this is the value of I and E, right? If the angle of incidence is I, then this is E, right? If the angle of incidence is E, right, the value of angle of incidence is E, then angle of emergence is I. Okay, so we can consider this as I or E. Okay, 42 degree, you can consider this as I or E. You can consider 62 degree as I or E. Okay, what is the angle of incidence when it is undergoing minimum deviation? Okay, so we know the relationship between angle of deviation, angle of incidence, angle of emergence and angle of prism, right? So let us find the angle of, here we need to find angle of incidence, right? Angle of incidence. Okay, so now angle of deviation delta is equal to I plus E minus A, right? Angle of incidence delta is equal to I plus E minus A. Angle of deviation is given, right? Isn't it? Angle of deviation is given. Angle of incidence and angle of emergence is also given, right? Either it's 42 degree or 62 degree, okay, or 62 degree or 42 degree. Now let us find angle of prism. Okay, so delta equal to 44 degree, which is equal to I. So I am going to take I as 42 degree plus angle of emergence 62 degree, which is minus A. Okay, now the value of A is equal to 42 plus 62 is 104. 104 minus 44 is 60. So the angle of prism is 60 degree, right? So now we can easily find here the angle of incidence, right, when it is undergoing minimum deviation, isn't it? So delta M, delta minimum is equal to, what is the condition for minimum deviation? I equal to E, right? I equal to E, and the ray which is refracted, right, the refracted ray which is in the prism must be parallel to the base, right? So I equal to E and R1 equal to R2. These are the conditions for minimum deviation. So delta minimum equal to I equal to E, right? So this will be 2I minus A, right? So I we need to find. We have the value of A, we have the value of delta minimum. So here I is equal to delta minimum plus A divided by 2, right? So here this will be I equal to delta minimum. Here the delta minimum is 38 degree, right, plus A is 60 degree divided by 2. Now solve this, you will get 49 degree. So the correct option is A. Okay, yeah. Next question, question number 17. A point object is moving uniformly towards the pole of a concave mirror of focal length 25 cm along its axis as shown in the below. The speed of the object is 1 meter per second. Here the speed of the object with respect to the mirror, okay, which is equal to 1 meter per second. At t equal to 0, the distance of the object from the mirror is 50 centimeter. Okay, the average velocity of the image found by the mirror between time t equal to 0 to time t equal to 0.25 second is. Okay, so let us here the average velocity is total distance traveled by the object divided by total time taken, right? Here total time taken is 0.25, right? Let us find total distance traveled by the object, right? So here, how to find the total distance traveled by the object, right? So velocity of the object is 1 meter per second, right? The speed of the object is 1 meter per second, right? And here, at here, what is the position of the object, okay? Or what is the distance between the pole and the object after 0.25 second, right? After 0.25 second. Now distance d equal to velocity into time t, right? That is distance traveled by the object is equal to velocity into time t. Velocity of the object is 1 meter per second, right? T equal to 0.25. So but here everything is in centimeter, right? So 1 meter per second is 100 centimeter per second. Now distance is in centimeter, right? So d is equal to here 100 centimeter per second into 0.25, right? So distance 2 equal to 25 centimeter. Okay, so that is object traveled 25 centimeter in 0.25 second, right? So what is the initial position of the object? That is 50 centimeter, right? From the pole of this concave mirror, right? So it travels 25 centimeter towards the mirror, right? So after 0.25 second, object travels 25 centimeter, right, towards the mirror, isn't it? So where will be the object now, right? Now where is the object? The object is at the focal length of the mirror, right? Object is at focal length of the mirror, right? Whenever you place the object at the focal length of the mirror, image will form at infinity, right? Image will form at infinity. So now here when the position of the image is at infinity, right? The distance between the pole and the position of the image is infinity, right? Now the average velocity v equal to, what is the average velocity of the image, right? V average is equal to total distance traveled by the image, that is infinity, right? Infinity divided by 0.25, which is equal to infinity only. So the correct option is C. Question number 18. An object is placed at a distance of 20 centimeter from the pole of a concave mirror of focal length 10 centimeter. The distance of the image formed. Okay, here the focal length of the concave mirror is 10 centimeter, that is f equal to minus 10 centimeter. We know that focal length of the concave mirror lies in front of the concave mirror, right? And u equal to minus 20 centimeter because object is always in front of the concave mirror, right? The distance of the image formed is, that is we need to find the value of v, right? Very simple question, right? Apply mirror formula. 1 divided by f is equal to 1 by v, 1 by u plus 1 by v. Okay, 1 divided by v. Okay, so now 1 divided by v equal to 1 by f minus 1 by u. So v equal to f into u divided by u minus f. Okay, so v equal to here f into u, right? F into u is minus 10 into minus 20, minus 10 into minus 20 divided by u minus f. U minus f is minus 20, minus into minus plus, right? So plus 10, isn't it? So v equal to here this will be minus 200, right? Sorry, plus 200 divided by minus 10. So v equal to minus 20 centimeter, right? Or you can, without solving this, you can find out the correct answer. How? Mirror, right? Isn't it? You don't need to solve all these things, okay? Just use the logic. Mirror, right? Object placed at the 10 centimeter from the pole of the concave mirror, right? The focal length of the, sorry, this is 20 centimeter, not 10 centimeter, okay? Minus 20 centimeter. What is the focal length of the concave mirror? It's 10 centimeter, right? F equal to 10 centimeter, minus 10 centimeter, right? So we need to find the position of the image, right? So where the object is kept, here object is kept at 2f, right? 2 times the focal length of the concave mirror, right? Object is kept at 2f, right? So when the object is at 2f, then the image will also form at 2f, right? Then the image will also form at 2f, and it is real and inverted. The size of the image is same as the size of the object. So the position of the image is 20 centimeter from the pole. So whether it is negative or positive, it's negative, right? So option C is the correct answer. Okay, you don't need to solve all these things, just use the logic. Okay, but here I am doing both way. Yeah. Question number 19. A candle is placed 25 centimeter from a lens, forms an image on a screen placed 75 centimeter on the other side of the lens. The focal length and type of the lens should be. Okay, we can easily say the type of the lens, right? How? Because here the image is forming on a screen, right? Isn't it? So when the image forms on a screen, the image should be real inverted, right? Real and inverted. So which lens forms image, real image and inverted image? Convex lens, right? So option B and D both are eliminated, right? So we have to find the correct option between C and A, right? That is, we need to find the focal length, right? So here convex lens, right? Candle 25 centimeter from the convex lens, screen, the image forms on the screen, and V equal to 75 centimeter, that is image distance, right? We have V and U. Find the value of F. Apply lens formula. 1 divided by F equal to 1 by V minus 1 by U. So 1 divided by F is equal to, what is the value of V? 75 centimeter. So 1 divided by 75 minus 1 divided by minus 25, that is plus. So 1 divided by 25. So 1 divided by F is equal to 1 divided by 25 into 1 plus 1 by 3. 1 plus 1 by 3 is 4 by 3, right? So F is equal to 4 divided by 3 into 25, 75, right? F equal to, you solve this, you will get 18.75 centimeter. So option A is the correct answer. Okay. Next question, question number 20. During scattering of light, the amount of scattering is inversely proportional to dash of wavelength of light. The direct question, okay, the amount of scattering is inversely proportional to 4th power of the wavelength of light. Okay, 4th power of the wavelength of the light, right? Light. So option D is the correct answer. Question number 21. A linear object of height 10 centimeter, HO is equal to 10 centimeter, is kept in front of the concave mirror. Okay, concave mirror. Okay, 10 centimeter. Okay, AB is 10 centimeter. Concave mirror of radius of curvature 15 centimeter. R equal to minus 15 centimeter. Right? At a distance of 10 centimeter. Here the object is kept in front of the concave mirror of radius of curvature 15 centimeter at a distance of 10 centimeter. That is U equal to minus 10 centimeter. Right? Radius of curvature is minus 15 centimeter. So the focal length F must be equal to minus 7.5 centimeter. Right? The image formed is, okay, so here the image formed by the concave mirror is real and inverted, right? So now we need to find whether it is magnified or diminished. Okay, anyway it is inverted, so option C and A both are eliminated, right? So we need to find the correct option between B and D. A and C are eliminated, so we need to find the correct option between B and D. That is, we need to find whether the image is diminished or magnified. So how to find? We know the mirror formula, right? So 1 divided by f is equal to 1 by v plus 1 by u, right? So let us find v. We know the value of u. We know the value of f, right? So f is minus 2 divided by 15, right? This is the focal length of the concave mirror, which is equal to 1 divided by v plus 1 divided by u, that is minus 1 divided by 10. Now 1 by v is equal to minus 2 divided by 15 plus 1 by 10, right? So 1 by v is equal to, take 1 by 5 as common, this will be minus 2 divided by 3 plus 1 divided by 2. So minus 4 plus 3 is minus 1, so minus 1 divided by 6, right? 6 into 5 is 30. So v equal to minus 30 centimeter. V equal to minus 30 centimeter, right? Okay, we have the value of v, right? So we can easily find the magnification. The magnification m is equal to here minus v divided by u, right? M is equal to minus v is minus of minus 30 centimeter, that is 30 centimeter, right? Divided by u. What is the value of u? Here u is 10 centimeter, right? Minus 10 centimeter, minus 10 centimeter, centimeter will get cancelled, so this will be 3, minus 3. Okay, magnification is minus 3, right? So what is the height of the object? Height of the object is 10 centimeter, right? So height of the image by height of the object is equal to minus 3, right? Height of the image is minus 3 into height of the object, that is 10 centimeter. So height of the image is equal to minus 30 centimeter. So negative sign indicates inverted, right? I already told you, here we are using concave mirror, so we will get inverted image, right? So I have proved, right? So it's inverted image and it is magnified or diminished. Actually it is magnified, right? But it is inverted, isn't it? Height of, compare the height of the object and height of the image. Height of the image is greater than height of the object, right? The negative sign indicates inverted, so it is magnified. Height of the image is magnified. Sorry, image is magnified and inverted. So option B is the correct answer. Okay. Next question. Question number 22. A plain glass plate is placed over a various colored letters: violet, green, yellow, red. The letter which appears to raised more is, okay, that is, it is shifted, right? So we know the shift formula, right? D equal to T, that is thickness of the glass plate, into 1 minus 1 by mu, right? So how I got this formula? By using the real depth and apparent depth concept, right? So refractive index mu equal to real depth divided by apparent depth. From this concept I got this formula. Okay, so if you don't know how I got this formula, just go through the derivation. Just go through the derivation in NCERT, it is there. Okay, shift or raise of the image, okay, because of the refraction. Yeah, we know that the refractive index mu equal to Cauchy's formula, a plus b by lambda square plus c by lambda to the power 4 and so on, right? So from this I can say, as the value of lambda increases, mu value decreases. As the value of lambda decreases, mu value increases, right? Isn't it? Mu value increases, right? So here the mu value has to be maximum, right? So then only here the mu value has to be maximum, right? Then only the shift will be more, right? The shift will be more, isn't it? So which color has the lesser refractive index? Sorry, maximum refractive index. The maximum refractive index for red, sorry, for here the maximum refractive index is for violet color, right? Why? Because violet color has lowest wavelength, isn't it? Violet color has lowest wavelength, right? Isn't it? So then the value of mu is maximum, right? If the value of mu is maximum, then 1 by mu value decreases, right? Isn't it? Then the raise will be more, isn't it? Or shift will be more. So for violet color, the letter which appears to be raised more is in violet. Okay, violet letters, the letters which is in violet appears to be more raised, right? So option D is the correct answer. Okay, yeah. Next question, question number 23. A ray of light passes through 4 transparent media with refractive indices n1, n2, n3 and n4 as shown. The surface of all media are parallel if the emergent ray DE, okay, is parallel to the incident ray AB. Then, okay, so for successive refractive index, mu sin theta is equal to constant. Everybody knows this one, right? If you don't know, then remember this. For successive refractive index, mu sin theta is equal to constant, right? So mu1 sin theta 1 is equal to, okay, here they said n, right? It's n. So n1 sin theta 1 is equal to n2 sin theta 2, right? n1 sin theta 1 is equal to n2 sin theta 2. Sorry, this is n4, not n2. Sorry, this will be n4. n4 sin theta 2, right? n4 sin theta 4, right? n4 sin theta 4. Theta 1 is equal to theta 4, right? Why? Because the rays AB and DE both are parallel, right? Or DE is in parallel with AB, right? So theta 1 is equal to theta 4, right? So n1 into sin theta 1 is equal to n4 sin theta 4. Okay, so n1 equal to n4. So the correct option is A. Okay, yeah. Next question, question number 24. Focal length of a convex lens is 20 centimeter and its refractive index is 1.5. It produces an erect enlarged image if the distance of the object from the lens is, okay, so here the convex lens produces erect and enlarged image that is virtual image, right? So when the convex lens produces virtual image, if the object is in between the focal length of the convex lens and the pole of the convex lens, okay, or the optical center of the convex lens, okay, when object placed between focal length of the convex lens and the optical center of the convex lens, then it produces virtual image, that is erect and enlarged image, okay. So what is the focal length of the convex lens? 20 centimeter, right? Right. So object has to be placed between 0 to 20 centimeter. So the correct option is C, right? So it has to be placed between 20 to 0. So that is 15 centimeter. 15 centimeter is less than 20, right? So option C is the correct answer. Next question, 25. A ray of light suffers a minimum deviation when incident on an equilateral prism of refractive index √2. The angle of incidence is, okay, so it suffers minimum deviation, right? Refractive index of the prism is given and we know the angle of prism, that is 60 degree. But why? Because the given prism is equilateral prism, right? So we need to find angle of incidence. Yeah, so let us find the angle of minimum deviation. Okay, so then we know the relationship between angle of minimum deviation, angle of incidence, angle of emergence and angle of prism, right? From that we can easily find the angle of minimum deviation. So now how to find the angle of minimum deviation? We know the refractive index of the prism formula, right? Refractive index of the prism mu equal to sine of A plus delta m by 2, that is angle of minimum deviation, divided by sine of A by 2, right? So A is 60 degree, right? Mu is √2. So √2 is equal to sine of, here A by 2, that is 30 degree, plus delta m by 2 whole by sine of 30 degree. Okay, now sine 30 degree is 1 by 2, right? So take sine 30 degree to the other side. √2 by 2 is equal to sine of 30 degree plus delta m by 2, right? √2 by 2 is 1 by √2, right? Then take sine inverse. So sine inverse of 1 by √2 is equal to 30 degree plus delta m by 2, right? Sine inverse of 1 by √2 is 45 degree, right? 45 degree minus 30 degree is equal to delta m by 2, right? Now delta m is equal to 30 degree. This is the angle of minimum deviation. Okay, we got the value of angle of minimum deviation. Let's find the angle of incidence. The ray of light suffers minimum deviation, right? Isn't it? So what is the condition for minimum deviation? One of the condition for minimum deviation, angle of incidence is equal to angle of emergence, right? So the relationship between delta I, E and A is delta equal to I plus E minus A. Now delta M is equal to 2I minus A, right? Now delta M is 45 degree, right? We need to find the value of I. So I is equal to here delta M plus A divided by 2, right? Now I is equal to delta M, that is 30 degree plus A 60 degree divided by 2. Now I equal to 45 degree. That is angle of incidence. So option B is the correct answer. This is equal to angle of emergence also. Okay, if they ask you to find angle of emergence, you have to follow the same method. Okay, this year they asked angle of emergence. Okay, last year they asked angle of incidence. This year they might ask angle of emergence. Okay, question number 26. Calculate the focal length of a reading glass of a person if his distance of distinct vision is 75 centimeter. Okay, so here we need to find the focal length of the reading of a glass of a person. The least distance of distinct vision is 75 centimeter for him, right? So here he has to wear a glass so that he can read any book, okay, or any newspaper which is 25 centimeter from his eyes, right? That is least distance of distinct vision for normal eye, isn't it? For him it's 75 centimeter, right? Isn't it? So here u equal to minus 25 centimeter, right? U equal to minus 25 centimeter, isn't it? That is the object distance, right? Isn't it? So he needs to correct his vision, right? Isn't it? So what is the least distance of distinct vision for him? It's 75 centimeter. That is V equal to minus 75 centimeter, right? V equal to minus 75 centimeter. Now 1 divided by F is equal to, apply lens formula, 1 divided by F equal to 1 by V minus 1 divided by U. Now 1 divided by F equal to 1 divided by V, that is minus 75 centimeter, minus 1 by U. U is minus 25 centimeter, so it is plus 1 divided by 25 centimeter, right? So solve this, you will get F equal to 37.5 centimeter. So the correct option is A. Okay, the correct option is A. Yeah. Next question. Question number 27. A person wants a real image of his own 3 times enlarged. Where should he stand in front of concave mirror of radius of curvature 30 centimeter? Okay, the first thing, the focal length of the concave mirror or the focus of the concave mirror lies in front of the concave mirror, right? So the radius of the curvature is also lies in front of the concave mirror. So R equal to minus 30 centimeter. So F equal to minus 15 centimeter, right? Focal length is R by 2, half of the radius of curvature of the concave mirror, right? Okay. Here what is the magnification? The magnification is 3, right? M equal to 3. So now it is positive 3 or negative 3? So it is negative 3, right? Isn't it? So why it is negative 3? Here he is using concave mirror, right? He is using concave mirror. So the image forming on the screen is inverted and enlarged, right? So M equal to minus 3. So negative sign represents the inverted. The image is inverted, okay? So magnification for mirror is minus V by U, right? So V equal to 3U, right? V equal to 3 into U, right? Okay. So here what we need to find? Here we need to find the value of U, right? Apply mirror formula. The mirror formula is 1 divided by F equal to 1 by V plus 1 by U, right? 1 by v plus 1 by u. Now focal length is 15 centimeter, minus 15 centimeter, right? So 1 divided by minus 15 is equal to 1 divided by 3u plus 1 divided by u, because v equal to 3u, right? So 1 by 3u plus 1 by u, right? So now solve this, you will get minus 1 divided by 15 is equal to 4 divided by 3u, right? 4 by 3u, isn't it? So now here u equal to 4 into minus 15 divided by 3. 3 5s are 15, right? So it is minus 5. Minus 5 into 4 is minus 20. So u equal to minus 20 centimeter. So what is the meaning of negative sign? The negative sign indicates he is standing in front of the concave mirror, or we can say the direction of the measurement of u is opposite to the direction of the incident ray, right? So in magnitude u equal to 20 centimeters. So the correct option is B. Okay, yeah. The next one, 28. If epsilon naught, mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then refractive index of the medium is. Okay, so refractive index of the medium, n equal to root of epsilon r into mu r. So what is the meaning of epsilon r? Epsilon r is relative permittivity. Okay, relative permittivity of the medium. Mu r is relative permeability of the medium. Okay, so what is relative permittivity? Relative permittivity is equal to the ratio of the permittivity of the medium to the absolute permittivity, right? Similarly, mu r, that is relative permeability, is equal to ratio of the permeability of the medium, okay, permeability of the medium to the absolute permeability, right? So now substitute epsilon r and epsilon r to this equation, n equal to root of epsilon into mu divided by epsilon naught into mu naught. So this is the refractive index of the medium. So the correct option is A. Okay, yeah. The next question, question number 29. An object is placed at 20 centimeter in front of a concave mirror, produces 3 times magnified real image, right? So m equal to minus 3, right? So the concave mirror is used, we are getting magnified real image, so m equal to minus 3, right? Negative sign indicates the image is real and it is inverted, right? What is the focal length of the concave mirror? Okay, what is the focal length of the concave mirror, right? So what is the value of u? U equal to minus 20 centimeter, right? So apply mirror formula, 1 by f equal to 1 by u plus 1 by v, right? 1 by f equal to 1 by u plus 1 by v. Okay, we know the value of u, we have to find the value of f, but we don't know the value of v, right? So how to find the value of v? We know the magnification, right? Isn't it? So magnification, here m equal to minus 3, right? So m is minus v by u, which is equal to minus 3. So v equal to 3 times u, right? V equal to 3 times u. Now 1 divided by f is, okay, f we need to find, equal to 1 divided by u is minus 20 centimeter, right? So minus 1 divided by 20, now plus 1 by v, right? V is 3u, u is minus 20, right? So minus 1 divided by 60, right? So 1 divided by f equal to, take 1 by 20 minus 1 by 20 as common, so this will be 1 plus 1 by 3. 1 plus 1 by 3 is 4 by 3. So 1 divided by f is equal to minus 1 divided by 20 into 4 by 3, right? So 4 5s are 20, 5 into 3 is 15. So f equal to minus 15 centimeter, right? What is the meaning of negative sign? The meaning of negative sign is the foci, or the focal length of the the focus of the concave mirror lies in front of the mirror, right? Lies in front of the concave mirror, or you can say the direction of the measurement of f is opposite to the direction of the incident ray. Okay, So in magnitude, f equal to 15 centimeter. So the correct option is B. Okay. Next one. Question number 30. A microscope is having objective of focal length 1 centimeter. That is FO equal to 1 centimeter. And eyepiece of focal length 6 centimeter. FE equal to 6 centimeter. If tube length is 30 centimeter, that is L equal to 30 centimeter, and image is formed at the least distance of distinct vision, what is the magnification produced by the microscope? Take D equal to 25 centimeter, that is least distance of distinct vision. Okay, so everybody should remember this formula. Okay, so the magnification of the microscope, remember this is microscope, okay, not simple microscope. So magnification of the microscope, M equal to L divided by FO into 1 plus D divided by FE. If you don't know how we, okay, remember this formula. Okay, if you want to know how we got this formula, go through NCERT. Okay, in there the derivation is given. Okay, so the magnification M is equal to L is 30 centimeter divided by FO 1 centimeter into 1 plus D is 25 centimeter, FE is 6 centimeter. Okay, so now M is equal to here 30 into here 6 plus 25 31 divided by 6. 6 5s are 30. So M equal to 155. So the correct option is D. Okay. Okay. Thank you. Thank you so much for watching this video. If you love this video, please like and share. Okay. So if you want to watch more such videos, please subscribe. Thank you.